Hello and welcome, fellow sandwich enthusiasts. I am thrilled to present my solution for the Lean Sandwich Shop case study with the University of Utah's Lean Six Sigma Green Belt certification class. In the following minutes, we will explore the operational efficiencies and inefficiencies of our Lean Sandwich Shop study case. So, without further ado, let's reimagine the future of the Lean Sandwich Shop. Lean Sandwich Shop is a new venture in the fast and casual dining industry. You and your team have been brought in as Lean Six Sigma practitioners to help stabilize one particular restaurant who has struggled since launch. This restaurant holds strategic value as it is the first in a large city, located downtown in a busy commerce district. If the restaurant does not experience a rapid turnaround, its poor reputation may impact the opportunity for additional sites. Lean Sandwich Shop is experiencing quality and productivity issues. Approximately 10% of their sandwiches receive complaints requiring a new sandwich. They fall behind on their orders throughout the day, and their operational costs are high due to scrapping or discarding of large amounts of expired food. The Lean Sandwich Shop is open 10 hours per day, 7 days a week, 365 days per year. Also, they are currently producing 600 sandwiches a day. If we look into the problem and take those numbers into account, we can see that their expected annual volume is 218,400. The cost of poor quality comes down to $120,120 per year. If we were to reduce that scrap rate from 10% to 2%, we would see a savings of $96,096 per year. The overall process has 7 different tasks, each of which has a certain number of employees and a certain amount of time it takes to complete each task. As you can see here, Task 1 has 3 employees, Task 2 has 1, Task 3 has also 1, Task 4 has 2, and so on. Task 1, which is record and deliver the order, takes 120 seconds. Task 2, which is receive the order and select bread, takes 15 seconds. Task 3, add protein to the sandwich, takes 90 seconds. Task 4, add vegetables and toppings, takes 120 seconds. Task 5, place the sandwich in the toaster, takes 165 seconds. Task 6, wrap the sandwich, takes 60 seconds. And Task 7, deliver the sandwich to the customer, takes 30 seconds. One of the most helpful and well-known Lean tools is called the Value Stream Map, as it provides you with a high-level visual view of the process, helping you identify flow and the source of waste. The Value Stream Map is described by including all of the activities, both value-added and non-value added, required to bring the product or service from creation to the customer. Once a Value Stream Map is created, you can also use it to calculate the process cycle efficiency by converting the WIP levels to the lead time, or also dividing the value-added time by the total lead time. Once we have analyzed the Value Stream Map, we can look into a work balance table. A work balance table is a bar chart used in Lean Six Sigma that helps visualize waste and identify opportunities to create flow by balancing the work between people. As you can see, here is our work balance table. We were able to calculate our takt time by dividing our daily available time by our customer demand, and it comes out to be 60 seconds, as you can see here. With that, we can now calculate the optimal number of employees, and that is done by dividing our total manual process time by our takt time. As you can see here, it comes out to be 10 employees, which is 2 less than we're currently at 12 employees. Another thing that we can calculate is our throughput per hour. At 12 employees, we are currently at 5. We'll come back to that in a little bit. One thing I do want to point out is task number 3. As you can see here, it's currently at well above 60 seconds, which is also above our takt time. Another thing we're able to calculate is our process cycle time. With that, we were able to better distribute the workload and create some efficiencies in the process. Next, we will look at a work combination chart. A work combination sheet is a tool used to separate man and machine hours. It helps us visualize the relationship between manual work and machine cycle time displayed as a Gantt chart. As you can see here, in task number 5, placing the sandwich in the toaster takes 165 seconds, which is a lot longer than any of the other tasks. Putting this into a work combination chart, you can see that we can eliminate about 145 seconds from this. It seems like the employees are waiting for the toaster oven to finish, which is a form of waste. They are either talking to other employees or they might try to help another area, but they are not performing a value-added task. We can rework the work balance table and come out with something like this. One of the things that we could do is combine tasks 2 and 3, along with tasks 4 and 5, and also 6 and 7. Move around some employees and bring it down to 10 employees like we had calculated earlier. Now, each one of our process cycle times is well below our takt time, which is what our goal is. Also, our TPH is now 6 at 10 employees. With that redesign, we can visualize that with a work cell design. A work cell is a floor layout shaped like a U and provides the opportunity to fluctuate volume by adding or reducing the amount of labor based on a customer demand. All of the value-added work is performed inside the work cell. This small design eliminates waste from moving and walking around. It also provides the opportunity to fluctuate volume in adding or reducing the amount of labor hours within the work cell, allowing employees to perform multiple tasks if necessary, such as task number 6, or actually no, task number 5, which was placing the sandwich in the toaster. By adding a heat lamp, we are able to maintain these employees busy as the sandwich is toasting, and then coming into task number 6 and 7. The result is a reduced number of employees and an improved TPH. As you can see here, our old process had 12 employees, now we're down to 10. Our TPH went from 5 to 6. Our total daily wages went from $1,800 to $1,500, which is a daily savings of $300. Looking into the year, that is an annual labor hour savings of 7,280, or an annualized labor cost savings of 109,200.